na screen yangu. I think I'll zoom in a bit also. Okay, so all right, so so we'll start with trying to define what regular expressions are. So if you just do a Google search, what are regular expressions, you will see, let me zoom in a bit. Wikipedia is saying a regular expression is a sequence of characters that specifies a search pattern in text. So, okay, let's try to deduce just that first line. So it's a sequence of characters. Okay, so we know what characters are. That specifies a search pattern. Okay, so let's try to deconstruct that, what that means. All right, so can we say that, for example, having one character, for example, tukiwa tuna like K, does that qualify as a pattern, or K O? Does that qualify as a pattern? Because they're telling us it's sequences of characters that specify a search pattern. So we need to understand what a pattern is before we can even do anything else. So I will go into this page hapa. Kila mtu ameweza kumanage kwa hii page, ameweza kunavigate to this page. Again. Okay. So just a brief introduction. So the first thing to recognize when using regular expressions is that everything is essentially a character. So that tracks with whatever tumeona kwa this definition, characters. Okay, and we are writing patterns to match a specific sequence of characters, also known as a string. So we are looking for a sequence of characters. That's what we're looking for. Okay, so most patterns use normal ASCII. So below are a couple of lines of text. Notice how the text changes to highlight the matching characters on each line. Okay, so before we even get to that point, so in JavaScript, there's two ways of writing regular expressions. The first one is you can use the Regex constructor. Now, this word should look familiar because we did objects. So you remember what constructors are. So hata kama mtu hajakwambia, if someone hasn't told you what, like how will it occur, you know for a fact that we can say let pattern is equal to, we know because it's a constructor, we will have a new keyword. Because we have a constructor that is constructing a regular expression. And then you use the regexp evo, and then you pass your pattern. So for example, Mike. So this is one way of writing regular expressions in JavaScript, or you can use the literal notation. So let's pattern, actually, what I can do, since I'm using let, I can just redefine it here. Pattern is equal to, now the literal notation is simply // and then your pattern here, evo. Okay, now let's talk about the pattern. So can anyone tell me why this is considered a pattern? Like Mike, why is Mike a pattern? Based off of definition, why is Mike considered a pattern? You want to figure out why we this is considered a pattern based off of the definition, which is patterns to match specific sequence of characters. There's basically sequences of characters. So the reason this qualifies as a pattern is because the only way to get this mic, this name, right, for this name to appear, you need to have a capital M followed by a small I, followed by a K, followed by an E. That's a pattern to form mic. So don't look at mic as the name, look at it as the characters. Up on the side, that's where the confusion normally starts. Look at mic not as mic a full name. Look at the letters, the characters. An M followed by an I, followed by a K, followed by an E. Don't look at the whole thing. So this is a pattern because we can only find this pattern if we follow these characters this way. So these are the two ways of writing regular expressions, but most of the time, this is what you're going to see. So when is it suitable to use, for example, this one here, the constructor, as opposed to mic? So, for example, let's say you don't know what your pattern is when you're writing your program. You don't know what the pattern is. At that point, you can use this new regular expression, this regex p, because you don't know your pattern beforehand. So you can just pass it down here like a value from a variable or something. But when you know the pattern beforehand, like we know we are looking for mic, then you can just pass it in here. So this normally is used when you don't know your pattern beforehand. So as you're writing your program, hujui ni what pattern you're going to be looking for. So at that point, you can use this constructor. But when you know your pattern beforehand, then you can use the literal notation. So we have our regular expression, but now we need to search, because the whole thing with the regular expression is we need to search for this pattern in a string. That's the whole thing with the regular expressions. They're just used to search, replace, modify. So we have our pattern here. And then we can also create like a sentence equal to this is a sentence. So the way to test whether our pattern exists in our sentence, because we want to see whether this sentence has the mic. Okay, put this here. Pattern is equal to mic, like that. So we have our sentence and we have our pattern. So now what we want to do is we want to go through this sentence and check whether we have the pattern in this sentence. So there's a few methods we can use. We can use the test method. So the test method is called on the pattern itself. So you say, if you want to now check whether sentence has our pattern, you say pattern dot test, and then you pass in the sentence that you want to test. So test will return either a true or false value, depending on whether you found the pattern. So now if I take this and I console log this, I think I already have my app running here. You can see we're getting a false because our sentence, this is a sentence, does not have the pattern mic. If we change this here and simply remove this and just have a mic here instead, you can see we now get a true value. So we have successfully gone through this sentence and then we found our pattern. Now, again, it's not matching at this thing as a whole. It's checking first of all the M, and then whether the M is followed by an I, then K, and then E. That's what it's doing with something called a regex engine, a regular expression engine, that is responsible for doing the matching. So when it goes through this sentence, it always matches from the left side. So kutoka huku, doesn't match from this side kwenda nyuma. It matches from M going to the right. So when it goes through this sentence, it will try to go through all of them. Kitafute, kitafuta. And here it will match first of all the M, then it will try to match the I, then the K, and then the E. And then because we are successful in finding that pattern, to return true value. So the test method is very good when you don't want to extract anything from your pattern or from what you got back. You just have to check whether it exists or not. We have another method called match. So match will not return a Boolean value. It will return an array if we find something, and if we don't find the match, it will return null. So let's try. And then another difference is the match method is not called on the pattern, it's called on the sentence. So as you can see here for the test, we said pattern.test. So the method exists on the pattern itself, on the regex, not on the sentence, not on the string. But for the match, you call it on the string, on the actual sentence that you want to test. And then you pass in the pattern. So let's console log this. So you can see we get an array back with way more information. So the index of your match, so you can see it matched from index 10, which is here. So it's way more information. It's just a Boolean value. So this one is very good when you want to extract some information from the match. The test, on the other hand, is very good when you're trying to just find out whether something exists, whether the pattern exists or not, true or false. That's it. But the thing I want you guys to remember is, it's not matching Mike, like vile si tunaiona as people, because you and I are going to read the whole thing as like Mike, like a sentence, a word. But the regex engine is actually reading the character one by one, one by one. That's what it's doing. So it can be a bit hard to wrap your head around that. But if you can think about it that way, it's going to be very easy for you to even understand what is going on when you're matching stuff. So currently, this mic is case sensitive, E pattern upper. If we try to match for mic with a small m, it will not work. You can see we get false from the test method, it will get null from the match method, because it's case sensitive. But we are provided with something called flags. So the I flag is used to tell the regex, ignore the case. Hence the I, ignore the case. So Mike with a capital M and Mike with a small m will both match. And then let's say, for example, we have more than one instance of Mike. So what happens is when the regular expression is matching, by default, the regex engine will only, so once it matches the first match, ikisha match Mike here kwanza, even if we have another Mike here, it will not even try to go uko. Itaachana nayo at this point when it matched the first time and then return the value. But what if you wanted to match multiple times, all occurrences of Mike? Then at that point, you'd use now the global flag. As you can see, this remains the same because this one returns a Boolean value. But for the other one, the match method, it returns 2 mics. If I change this one, just to show you that it's actually matching both, for capital M, we'll see this last one has a capital M. If I put another one, it will also match that one. So now we are matching all occurrences of Mike, as you can see. Any questions up to that point? Something I need to explain again? So the test method, there's more methods, but just to make things a bit so that we don't get confused, we'll just use these two for now. So test and match. And then once we have enough grasp of regex, then we can move on into other ones. There's one called exec, and there's a bunch of other ones, but we'll just look at these two for now. So the test method is called on, on the actual pattern. So it's pattern dot test on the actual regular expression. And then the match is called on the actual sentence. So the input that you're trying to match. That's the only difference, other than the one is returning a Boolean value and one is returning an array. Any questions up to that point?
Hi Ian.
Hi.
I just joined. Could you just do like a brief recap of what you've covered? Sorry.
Okay. All right. So, so the first thing we did. So before I even go on, can you guys navigate to this website because we are going to be using it. So I'll share the link in the chat. Let's go to that website because you're going to make use of it today. Okay. All right. So when we started, we were first of all defining what regular expressions are. And first of all, like just did a Google search. And according to Wikipedia, it's a sequence of characters that specifies a search pattern. So just using that definition, right, we can see we have characters involved. We can also see we have some sort of searching going on. Then we can also see that there's patterns, like patterns of text. So basically, regular expressions are a way to search for patterns. Okay, so you're always going to be working with some sort of character. So then we moved on into this page, which again gave us a brief description. So the second paragraph is saying the first thing to recognize when using regular expressions is that everything essentially is a character. Okay, and we are writing patterns to match a specific sequence of characters. Now, the keyword again is characters, not strings. We are not looking for Mike as a whole thing. We are looking for characters, patterns. So Mike is a pattern because the only way to get this pattern is if you have an M followed by the letter I, followed by a K, followed by the letter E. Because that's how it's going to look at it, the regular expression. There's something called a regular expression engine that is responsible for checking whether your tests are passing. So when it's going through the search, right, when it's searching for this pattern called Mike, it's not looking for the whole thing all at once. It first of all checks for M. If M passes, it now checks for I. If I passes, it now goes to K and then E. So when it comes here, so when we start searching for the values, it's going to go like that, step by step, one letter after the other, one character after the other, until the whole thing matches. And there's two ways of writing regular expressions in JavaScript. You can either use the regex p constructor. So we did constructors when we did objects. So you can see the new keyword is right here. So new regexp, then you pass it in your pattern that you want to search for. Then you can also use the literal notation. So the literal notation is just simply 2 slashes. So if I just remove this, this, then you pass in your pattern apple. And then we have things called flags. So right now, if I try to match this mic pattern using this sentence, it's going to come back false. And let's see that in the console. You can see we're getting a false value because by default, the patterns are case sensitive. So if you want to make your patterns not case sensitive, then you pass in the flags. Pass in the I flag to tell it doesn't matter what case it is in, as long as it's mic. So capital M, small m, return true. And then, what if you wanted to find all instances of mic? Now, the way the regular expression engine works is when it finds the first match, it stops executing. So right here, when it was going through this sentence, the minute it found a match, it stopped looking for any other matches and returned the results back to the program. But what if we wanted to find all occurrences of Mike? So now the test method will always return a Boolean value. So you'll not be able to see the difference. So when you're trying to use the test method, you call the test method on the pattern, on the actual regex. And then as an argument, you pass in the actual sentence that you want to test. So test is always going to return a Boolean value. So it's very useful when you just want to check whether that pattern exists. You don't care about extracting any characters from the match. And then the match method now is used when you want to now get more information about your match. And the match method is called on the sentence, not on the pattern. As you can see, we are saying sentence.match, then you pass in the actual pattern that you want to search for. Now this one returns an array. So this one returns a Boolean value, the test method, and this one returns an array with some information about your match. Now, if we had another Mike here, the result has not changed, right? Just look at this place. We still have an array with just one Mike. If I even come and change this to capital M, we're still just getting the first one. That's because the regex engine, the minute it encounters this Mike, it stops trying to look for any other matches and returns that value. But if you want to find multiple occurrences, then you can also append the G flag, the global flag. So you can see our test is still just giving us a true value. And then the match is now giving us two things, the first mic and the second mic. If you add another one, it will now find all of them. Is it clear?
Yes. I have a question. So in your sentence, you have both vowels and consonants. Can you use regular expressions to okay, there's a problem I saw on HackerRank, and one of the solutions was using regular expressions to print it out. Let me just get the link to the. Can you use regular expressions to solve this? Because I did not understand that solution. To like print out the vowels first and then the consonants after.
Did you send the link?
Yes.
Okay. All right. So let me just open it and then see. I think it's HackerRank. I think I need to log in right now. Oh, I think I actually know this problem. I think I've seen it before. So I think what we can do so that we don't spend so much, you can definitely use regex. So what we are going to do is, so after today's session and tomorrow's session, based off of what we'll have learned, we'll try to solve it. Because now, if we try to do it, everybody's going to just get confused. So we'll do today's session, go through the different topics, and then now tomorrow we can try to solve it.
All right. Yeah. Thanks.
Okay. Okay. So anybody else with a question up to that point? Anything I need to redo again? But the thing to remember is character. We are matching characters. Don't look at Mike as like full name. Try to readjust your mind to look at M-I-K-E. So now we'll try the first challenge here, lesson 1. Okay, so go ahead and try writing a pattern that matches all 3 rows. Okay, so now how do we match this. We want all our test cases here to match. We want to put in a pattern here that will match this one. It will also match this, and it will also match this. Look at, you can go through it, try to see whether you can figure it out. What can we write as a pattern here? And here, by the way, we don't need to have this, they've already done it for us, so you just pass in the pattern. So for example, if you think that the pattern we need to put here to pass is, for example, the letter G, you just write G here. I think I can just do one.
ABC.
ABC. Okay. Okay. There's another one. What else can we put to have a passing for them to all pass other than ABC?
A to Z.
A to Z.
Yeah.
A to Z. How do we write A to Z?
And then
A dash Z.
Don't overthink it. Just look at the patterns. Look at what they're asking us to match. Remember what we are trying to do. We're matching characters. Like, think about it in terms of one character after the other. So ABC works because, just look at what Fatma said. ABC is matching because we do have that pattern. In all of them, we have an A followed by a B followed by a C.
So you can write A alone.
So we write A, that still works.
So B and C.
B still works, and C still works. Because we are looking for a character that is in all of them. We're not looking for a sentence or anything. A, B, C work because in all of them, we have A followed by a B followed by a C. If you try to look for D, the last one will not match because we don't have the D in the last test case. We try to just use E, the first two pass, but the last one does not. If we try to look for F, same thing. If we try to look for G, same thing. Now, let me try to explain this because this can get very confusing. Now, sometime last year, I wrote a blog about this, and I think this can help us understand this. So I'll open this a bit, and then I'll come back here. So now, in my example that I gave here, we were looking for, the pattern was Wayne. So the regex engine internally, what it's doing, right? It would look for W. The first thing it would look for that because we're trying to match Wayne in any case, capital or small. So the first thing it does, right? The regular expression, it knows this is the pattern we need to look for. So we first of all look for W, followed by the letter A, followed by Y, followed by N, followed by E. Now, in our case, in this instance, right, if we just give an A, it matches because in the regex engine, we just have a single A. So when it comes to check, it will find the A in the first one. It will also find the A in the second one. It will also find the A in the third one. Because now, if you look at this now this way, instead of having W, A, Y, N, and E, it just has one A. So if the one A is there, it will match. AB will also match because we have AB here, we have AB here, and we have AB here. But now our pattern has changed, right? Our pattern is now A and B. So it will match. And then ABC will also match because again, the pattern has changed because now here we have A, B, C. So it first of all matches A and then B and then C, and then it matches. Like, is it clear now why all the three are working? But if you put a D, the last one does not match because we don't have a D here, but we do have, so again, the pattern has changed. We now have A, B, C, and D. The first two will pass, but the last one will not. That's why you're getting 2 greens, but the last one is not passing. Is it making a bit more sense? Anyone with a question?
Yeah.
Mm-hmm.
Could a use case for this now be checking if an input is an email instead of using the default available input validation, and just test if there is an @ character somewhere?
Yes, it's actually a very common pattern to use. I think that's what is actually using internally, HTML. So your type email, it's probably validating using a regular expression. Because actually, when you hover on the input, so anytime you when you have an input type email and you input a wrong email type, there's a small pop-up that comes there that is a regular expression. So I don't know whether you've ever seen it, but they're actually using regular expressions internally to check whether you're actually passing in the right string. So you can use regular expressions for that. Okay. Good question. Anybody else before we go to the next one? Okay.
I have a question.
Mm-hmm.
Is Regex also used in search engines when you search for information and it returns what matches your query?
Yes, it is. Anything that has anything to do with search and replace or modify strings, regular expressions are the go-to. And that's why they are there in all the languages, all the programming languages, all of them have regular expressions. So they are very powerful, but they can get very confusing very fast, but they are used in search engines as well. They're even used in frameworks. We'll look at one example, like config files for frameworks, like for example, like Tailwind. Even React, when you're telling it what folders to look into, there's normally some asterisk somewhere that you put. That asterisk is a regex pattern. It's a regex thing. We'll cover it later, but that asterisk means something. It's also used a lot in, if you have like a Linux-based operating system, even grep, when you're searching for something in Linux, it normally uses regular expression. So they're everywhere. They're everywhere. Okay. Okay, so now characters include normal letters, but digits as well. In fact, number 0 to 9, blah, blah, blah. Okay, so what are they asking us to do? So basically, they're just telling us that you can also match digits because digits are in the ASCII table. So there is a shorthand syntax when you want to match digits only or all digits. You have this /d, /digits. So this will look for any digit between 0 and 9. So the preceding slash distinguishes it from the simple D character. So it's not the same as writing this. Now, if you do this, you're telling it, whatever I'm looking for, I'm not looking for the literal character D. I'm looking for the ASCII characters between 0 and 9. Like all numbers, that's what you're telling it. Okay, we look at more, there's more examples of that, like shorthand syntax. Okay, so let's go to the question. So below are a few more lines of text containing digits. Try writing a pattern that matches all the digits in the string below, and notice how your pattern matches anywhere within the string, not just starting at the first character. Okay, all right. So let's look at the test that we're trying to pass. So the first one is A, B, C, 1, 2, 3. Okay. The second is define 1, 2, 3. Okay. The third is var G1, 2, 3. Okay. Can anyone tell me what we need to write to pass all of them? What pattern do we need to write? Does anyone have
Yes.
Sorry, I didn't hear you. Is that Albert?
No, that was not me.
Okay. What do we write? We want to match all of them, all three. What pattern can we put in that will match all three?
1, 2, 3.
Okay, 1, 2, 3. Sorry. 1, 2, 3. Okay, that matches. What else can we put? So that's 1.
You can use a \D.
Okay, that also works. Any digit. But you can see it's changed. It's now just finding the first one. You can see whatever it's highlighting now is just 1. Because remember what I told you about the Regex engine. It finds the first occurrence and then stops looking for anything else. So in this case,
you can,
Mhm.
I wanted to say you can add a plus sign there after D.
Yes, we'll look at plus signs afterwards. But for now, we can just look at it this way. But remember, the regular engine now, at Regex engine now at this point, when you just give it Evo with just 1D, in the Regex engine, you just have one, it's just looking for one number, anything from 0 to 9, but just one. That's why it's only matching the first one, just one on all of them. Okay, what other pattern can match? So we can use the /D, we can match 1, 2, 3. What else? There's how many more left? I think 2 more. 2 more patterns. Two more patterns that can match.
Could it be 1, 2, and 2, 3?
1, 2, 1, 2. Okay, 1, 2 works. 1, 2, and 3 was already, that's what Fatma said. So there's
Yes,
one
2,
more.
3. 2, 3.
Okay. Actually, there was more than just 2. There's bado moja bado. 2, 3 also works. Actually, there are more than I thought, actually. So 2, 3 also works. So 1 will also work. 2 will also work. 3 will also work. Because remember, one digit, it's just looking for one digit within the whole thing. So you don't have to so when you just give it 1 in your, again, always have this mental image. At this point, we just have one value here, just one only. If it just finds 1, it will match. That's why just 1 will match, because 1 is here, 1 is here, and 1 is here. Same thing with just 2, same thing with just 3. But now when you start getting into 1, 2, now you have 2 things to match. Now you have 1 and then 2. So it doesn't match 2 before it matches 1. So in the Regex engine, the first one is 1 and then 2, but it will not match 2 before it matches 1. So 1 has to be matched before it can match 2. Same thing with 1, 2, 3. It will not match 3 before it matches 2. And it will not match 2 before it matches 1. Because it's going character by character. But when you just give it 3, it's just looking for 3 only, because in the engine, there's just 3 here. It doesn't matter where it is, the beginning, the end, it doesn't matter. As long as we have a 3 anywhere in our test cases, it will match. Same with 2, same with 1. Okay. Anyone with a question? I know it can be a bit confusing to wrap your head around, like looking at them not from the beginning to the end, but characters. Anyone with a question? Okay. Okay, so let's continue. Let's move on to the next one. Okay, so in some card games, the Joker is a wild card and can represent any card in the deck. Okay, with regular expressions, you are often matching pieces of text that you don't know the exact contents of, other than the fact that they share a common pattern or structure, e.g. phone numbers or zip codes. Similarly, there is a concept of a wildcard which is represented by the dot meta character and can match any single character, letter, digit, white space, everything. You may notice that this actually overrides the matching of the period character. So in order to specifically match a period, you need to escape the dot by using the slash accordingly. Same way when we did the digits. Wanted to escape the D, then you'd have the slash. Below are a couple of strings with varying characters, but the same length. Try to write a single pattern that can match the first 3 strings, but not the last 2 to be skipped. You may find that you will have to escape the dot character to match the period in some of the lines. Okay. I hope you guys have opened this on your end so that you can also read the problem statements. So what do they want us to do? So try to write a single pattern that can match the first 3 strings, but not the last. So match this, this, and this, but not this. So the wildcard, we're supposed to use the wildcard, which matches anything. So let's try it in the console first. Let's see what that pattern does. So if I come and I match anything here, let's see what it gives us. So you can see it's returning a true value here because you're matching anything. And then for the sentence, when you use the match, it's matching all of them because we told it match anything. It's also matching the white spaces. That's why you see our array also has white spaces. There's one here, there's another one here. So it's matching everything, literally everything in the sentence. Let's go back to that question. Below are a couple of strings with varying characters of the same length. Try to write a single pattern that can match the first 3 strings. So we need to match this, we need to match this, and we also need to match this, but not this. Okay, so let's try to think about it. So what is, you can see this one, we have cat, and then we have a full stop. Maybe you guys can see that. We have cat, and then a full stop. We have 896, and then a full stop. We have question mark, equal sign, plus, and then a full stop. And then here we have A, B, C, and then 1. Okay. So we are trying to match the first 3. We want to match cat, 896, and also this one. Any suggestions? How do we write that pattern? Let's take our time. Anybody with a suggestion? Try to work through it. Let's start with just a dot. Let's see what a dot does. If we just put a dot here. Okay, so you're matching the first 3. Right? You're matching the first 3. 3 dots.
And then a forward slash. and another dot.
Yes. Can you walk us through how you came up with that?
The first three dots to match all the first three characters, whether it's a letter, a digit, or a character, and then the / and dot to specifically match the period.
Okay. Yeah. So each dot represents anything. So let's think about it in terms of the regex engine again, right? So now in this instance, if you think about the regex engine, we have anything here, anything here, anything here, but the last one has to be a dot. That's why we are escaping it. Because now in my example here, right, same thing. If you want to escape it, then you have that. This is now not matching everything. You can see it's null because now we are looking for the period, a full stop. We're not looking for anything. So with the solution that Fatma has given us, it's looking for anything for the first one, anything for the second one, anything for the third, right? That's why this is matching, this question mark golden plus, because it doesn't care whether it's a number, whether it's a symbol, as long as it's within these first three. And then the last has to be a period or a full stop. Any question? Anyone who's getting left behind or something we need to redo?
So how is this applied in a real life example?
What exactly, the pattern or
The pattern.
this particular pattern?
Yeah.
It's difficult to give you an answer at the top of my head, but I will show you a config file after we've done a few more, because this is not normally how you do it. Don't pass in 3 dots. There is a simpler way to do this using the plus sign that someone mentioned. But I'll show you an example of a config file from, I think, Vite or React that uses the asterisks.
And actually, now related to that, could you show an example where now we use the / and the asterisk to identify files and folders?
Yeah, we'll do that example also. We'll go through the basics and then we'll do some challenges that will have us like look for folders that have like a .md file or a .js file. So we'll go through all those examples. Don't worry, we just want to get done with the basics. And then once you guys have a grasp of it, then we can start doing some challenges. Okay. Does anyone have another solution for this? Is there another solution?
Just if you eliminate the 3 dots, slash dot also work.
If I eliminate
You remove the preceding 3 dots.
this one.
Yeah.
Why is that working?
I think it checks the presence of the dot in all the strings.
Yeah. Yes.
Kuna time unaenda unapotea Ian. I
Just
don't know.
it's just matching the dot.
Yeah.
Yeah, that's a very, I don't even see that. Very smart. It's just looking for anything that starts with a dot. It will match this because this one has a dot here. Because now in the engine, it's just one dot. Yeah, just a dot. So because the last one doesn't have one, fails. Very nice. Okay. Let's continue. Okay, so matching specific characters. Okay, so the dot meta character from the last lesson is pretty powerful, but sometimes too powerful. If we are matching phone numbers, for example, we don't want to validate the letters ABC as being a valid number, so whatever that pattern. You don't want someone to write ABC and then dash DEF as a phone number. There is a method for matching specific characters using regular expressions by defining them inside square brackets. For example, the pattern ABC will only match a single ABC or AB or C letter and nothing else. Below are a couple of lines where we only want to match the first 3 strings, but not the last 3 strings. Okay, notice how we can't avoid matching the last 3 strings if we use the dot, but we have to specifically define what letters to match using the notation above. So we want to match the first 3 strings. So can, man, and fan. But we don't want to match dan, ran, and pan. Okay. Look at the question. Let's see whether we can figure it out. So let's look at what is similar between can, man, and fan. Okay. Look for similarities between those 3 matches. And then look at how the ones we're supposed to skip are different. And then based off of the example, the pattern ABC will only match a single A, a single B, or a single C letter and nothing else. So we're not matching A, B, C. We're matching either A or B or C. So how do we figure this one out? We want to match can, man, and fan. We don't want to match dan, ran, and pan. Remember the engine? Remember the Regex engine? Okay, so we want to match can, man, and fan. So if you think about it here, we want the first letter to either be a C, an M, or an F. That's what we want. And then the rest needs to be A and N. So the first letter needs to be one of those 3 letters. And then the rest of it needs to be followed by an A and an N. Anyone want to try and see whether they can figure it out?
We add the square brackets and then we add the first letters.
Oh, what do I write?
C, M, and F.
Yes. So it's only matching when the first, in terms of the regex engine, we're simply telling it only match when the first one here, the first character is either a C or an M or F. So if this is a C, it will match. If it's an M, it will match. If it's an F, it will match. You don't even need anything else. Very, very nice, Catherine. Is anyone confused as to why this one is working? Okay, any other solution? Don't think so. There is another solution, but this is the most, the least expensive. You don't need to do anything else. As long as it's matched these first 3, then it should work. Okay, so let's continue. So exclude specific characters. So in some cases, we might know that there are specific characters that we don't want to match. For example, we might only want to match phone numbers that are not from the area code 650. To represent this, we use a similar expression that excludes specific characters using the square brackets and the heart. For example, the pattern, square brackets, then the heart, and then ABC will not match any single character except for the letters A, B, or C. So we'll match any single character except for the letters A, B, or C. Okay, with the strings below, try writing a pattern that matches only the 5 animals, hog, dog, but not bog. Notice how most patterns of this type can also be written using the technique from the last session, from the last lesson, as they are really two sides of the same coin. By having both choices, you can decide which one is easier to write and understand when composing your patterns. So they're telling us we can use the square brackets. Okay, so we want to match hog, dog, but not bog. Okay.
You can use the square brackets and the hat, the circumflex thing, to skip the letter B. So in the square brackets, the
Trying to
hat
look for my,
symbol,
sorry. I was trying to look for it in my keyboard.
and then B. And then after the square brackets, O and G, then that would match the first two and not the last.
Okay, good. That worked. Any other solution? Any other solution that we can use? So we are only trying to match if we have H or D, right? That's another way to look at it. We are only trying to match if we have as the first character H or D. How can we rewrite this?
We can write it in the similar technique as the previous one, where you define square brackets and write H and D. It will only match these two. But you remove, no, not H and G, H and D, but you remove, yes. Yeah, this works.
What's confusing you there? So we are checking the first character. So the first character has to be a H or a D. So what do I remove? Is there anything else I need to remove here? Anything else I need to remove to make it match?
It's already matching, though I don't know whether the OG is redundant.
So do I try to remove it and see?
Yeah.
It works. Yes. Because we are just matching the first characters. It's either H or a D. So this will still match, yes, but it's unnecessary. We just want to match as long as H and D are present as the first character. That's how it's working. So that's two ways of solving it. Okay. And is there any other way to solve this? I'm trying to see if there is another way. Okay, I think we can continue. Okay. Okay, character ranges. Okay, so we just learned how to create a pattern that matches or excludes specific characters, but what if we want to match a character that can be in a sequential range of characters? Do we have no choice but to list them all out? So luckily, when using the square bracket notation, there is a shorthand for matching a character in list of sequential characters by using the dash to indicate a character range. For example, the pattern 0 to 6 will only match any single digit character from 0 to 6 and nothing else. And likewise, not N to P will only match any single character except for letters N to P. So multiple character ranges can also be used in the same set of brackets along with individual characters. An example of this is the alphanumeric /W meta character, which is equivalent to the character range A to Z, capital, A to Z, small, and then 0 to 9, and often used to match characters in English text. In the exercise below, notice how all the match and skip lines have a pattern, and use the bracket notation to match or skip each character from each line. So be aware that patterns are case sensitive, and A to Z differs from capital A to capital Z in terms of the characters it matches, lower versus uppercase. Okay. So what do we want to match? So we want to match capital A followed by small n followed by small a. We also want to match Bob, which is capital B, small o, small b. We also want to match CPC, capital C, small p, small c, but we want to skip small a twice and x, small b twice and y, small c twice and z. Okay, so how do we write that pattern?
We'll first match the capitals A to C in square brackets. And then because the first string contains an N and the third one contains a P, and they're both in small case, we'll have another pair of square brackets matching the letters N to P.
So N to P small?
Yeah.
N to P.
And then another pair of square brackets to match the last ABCs in small. Yeah.
So we have matched, so we are matching everything on the first one, Anna. We are also matching everything on the second text, Bob, and also matching everything on CPC. Okay, good. Does anyone see another solution? Can anyone see a different solution? Because now in this case, in Fatma's solution, we are matching everything. The A, the N, and the A. The B, the O, and the B. The C, the P, and the C.
In the solution that Professor has posted.
Okay, let's try that. See whether we, okay, very interesting solution. That's Vekesa's solution. Okay, sir, do you want to walk us through your solution?
Okay, so I'm using the heart
Mm-hmm.
to remove all the skips.
Mm-hmm.
Yeah, so the heart double X, it removes skip one. Then the heart double BY removes B, like that.
Mm.
Yeah.
Okay. But you're matching, are you matching? Where is the matching happening? Are you is it matching the first character or
It's matching the whole word.
the whole word?
Yeah.
Okay.
So I'm using an exemption. I'm exempting this instead of
Mm-hmm.
now. It's actually the opposite of the
Mm.
other.
Okay. Okay. So does anyone agree with Professor? He's matching the whole word. You guys think?
Um,
Hmm? You're saying something, Catherine?
oh no, I thought I saw an error somewhere.
Mm. Okay. All right. So remember that when you're doing the matching, right? So this is here. You're negating. What are you negating here? Professor is saying he's negating A and X. So he's negating this as long as it doesn't start with this, right? But what if we did this instead? What am I trying to do? There's something else I'm trying to do here. You do know this is matching a single character.
It's not matching a range.
A range between
A to X.
A to X small. No, because this right here is not a range. This is not a range. Neither is this. Because a range is if you negate 0 to 9, a range. So as long as you're not including anything between 0 to 9 for your first character, just the first character. Okay, we see the red only on the first character. Trying to understand his solution. Okay, I think I will have a look at it later. But there was an even easier solution.
A to Z works instead of 0 to 9. But it only matches the first 3 letters, yeah.
Yeah. So to your solution, Fatma, you had actually already solved it with your very first character. So we are looking for, as long as we have a capital A, capital B, or capital C as the first character.
Yeah.
I think we can solve it that way. That still works because we are simply checking the first character. This range doesn't mean we're looking for the whole the whole word, just the first character. So this still works because this just represents a single character in your string. Yeah. Okay. Do we have time for one more? I think we can finish them up tomorrow. Let me see how many are left. Actually, quite a number. So alternatively, what we can do, instead of going one by one, you guys can try and do them on your own, whatever is left, and then you can show us your solutions tomorrow. Because it goes step by step, explaining everything. Like if you have repeating characters, how do you match for that? Matching groups, nested groups, and all that good stuff. And then now once everybody is done, we can look at the challenge that Fatma sent. Sounds like a plan?
Yes.
All right. So I hope you guys are understanding now, Regex. I hope that they're not as intimidating as they might have seemed before. So take some time to practice, and then tomorrow, in tomorrow's session, I'll ask you guys like what solutions you are able to come up with. So try to finish as many as possible, and then tomorrow we'll check them out. So let me stop sharing. Thank you for joining the session. Does anybody have a question? Anyone with a question?
You have to show config file where it works.
Yeah, I'll show you in tomorrow's session because now I need to open it. And we still haven't covered the asterisks. What do you call a session that is after? I think you can just open one. No, I don't think we have enough time. I'll show you tomorrow. But open any React file, like any config file for Tailwind or anything. Actually, if I go into Tailwind, the config file does use the asterisks when you're giving it the content. It should make more sense tomorrow. No, it is. It's in the get started. Now, we'll look at this symbol tomorrow. This one. It's called the quantifiers. They're called quantifiers. So this is, we are using regex here. It might be using a package called glob, but glob is using regular expressions. Glob is something that you use to find all news npm. This package. It's used by a lot of libraries, but it is
Are we
using.
supposed to be seeing your screen?
Sorry, forgot
Because
that I
we
was not.
don't.
Forgot I was not sharing my screen. Let me share my screen. Okay, is it visible? You can see my screen, right? I'll assume that's a yes. So right here, here, this section here for the Tailwind config file, we are using regex here. This asterisk is a quantifier because you're telling it match this thing 1 or more times or 0 or more times. there's also a very popular package called Globe. This is using Regex. See, it has 93 weekly downloads. See, it's the same thing here. Yeah, so regular expressions are very, like things like what is it called? If you've ever used Nodemon will just look for all JS files, one or more, using that asterisk. So it is used a lot, but we'll like do a deep dive now tomorrow. Okay. All right, so I'll see you guys tomorrow. We'll finish up on the remaining challenges, and you guys can go through them on your own. And then tomorrow, you can show us your solutions, or if you got stuck in one of them, we can try to work out how to do it together. So you guys enjoy the rest of your evening. I see Albert also had a solution. Sorry guys, sometimes I don't see the chat because I'm normally sharing my code, so I don't normally see what you guys are writing. But probably you guys can be telling me when someone ameandika kwa chat. That way I can know. But other than that, I'll see you guys tomorrow. Enjoy the rest of your evening and keep practicing magic. Bye.
Thank you, Ian.
All right, bye.
Okay.
Bye.